Alright guys, section 2.2, solving inequalities using addition or subtraction. How can you use addition or subtraction to solve an inequality? Really, this is just carries over from chapter 1, where you use inverse operations, and you just have to remember that to maintain principles of equality, if you do something on one side, you've got to do it to the other. So the core concept, addition property of inequality, is essentially the same thing as the addition property of equality. If you do it on one side, you got to do it to the other side. So instead of making the barrier at the equal sign, we are making the barrier now at the inequality sign. Right? And I'm actually gonna, I should make those way thinner. But that's it. That's the main concept. If you understood it in chapter 1, this is going to be a piece of cake. If you didn't understand in chapter 1, then we will just have more opportunity to practice. So this addition and subtraction properties also apply to inequalities. So we got to use our inverse operations. If we look at this, we have an x minus 3, and we're always trying to isolate the variable, right? So in this case, we're trying to isolate x. This becomes plus 3, or to cancel out, then minus 3. So we have x is less than negative 4 plus 3 is negative 1. So let's just throw negative 1 somewhere in the middle. Negative 1 to the right are the numbers get greater. Negative 2, negative 3, negative 4. X is less than negative 1. Do you see an equal sign here? So what kind of circle will this be? This will be an empty circle. And less than is just to the left. Negative 2, negative 3, negative 4. Those are all less than. So we go that way. On your book, it should be, you should make that arrow a little thicker. I just don't want to play around with the lines too much. Here, h is on the right side of the inequality. Again, this is our little barrier, like the barrier that splits off into left and right is wherever the equal or inequality sign is. So plus 3, that's the right side, plus 3, that's the left side. 0 is greater than h. So another way of saying 0 is greater than h, greater meaning bigger, then if 0 is greater than h, what is h's relationship with 0? H must be less than 0. So you can leave it either way. It's just as long as you know that if you flip an inequality, so everything on the right goes to the left and everything on the left goes to the right, then the inequality symbol must also change. So we got 0, numbers to the right, 1, 2, numbers get greater, numbers to the left get lower, negative even, or in this case even more negative. Less than 0, no equal sign, so the circle will not be filled. Let's bump this up. So we're going this way, right? That's it. Moving on. S minus negative 1 is really S plus 1. 2 negatives make a positive, but that's not, please don't apply that to life. S minus 1, if you do it on the left side, you got to do it on the right side. S is equal to or greater than 1. So let's say 1, 0, negative 1, negative 2, 2, 3, 4. Greater than 1. Greater than or equal to, that means this got to be filled. What numbers apply? 2 is greater than 1, so if that's true, then I will go in that direction. And it is true, so I will go in that direction. 6 minus 9 is negative 3. Negative 3 plus u is less than negative 2. This is the dividing line that creates the barrier of where my left and right sides of the inequality are. Plus 3, plus 3. U is less than 1. So what does that look like? 1, 2, 3, 4, 0, negative 1, negative 2. U is less than 1. That will be an empty circle. Less than 0 is less than 1, so we could just go off to the left. Okay. Again, I'm showing you this now. If you understood chapter 1, then this is, this is the same thing, but we will practice more just for the sake of practice. 4c minus 3c is 1c. You don't have to write the 1. It's just you understand that there is a 1. Subtract 10. So I get 2 is less than or equal to c. So you know what kind of circle is this going to have? A filled circle. Again, the greatest numbers go to the right, and the lesser numbers go to the left. That's how number line works. If 2 is less than c, or less than equal to, I could flip it around. If it makes it less confusing for you, then you could, as long as you flip the c and the 2, as long as you also flip the inequality sign. So c is equal to or greater than 2. So we know we're going to start at 2. We know it's going to be filled. On your, obviously your circle doesn't have to be that big on your student journal. Greater than 3, 4, 5, those are greater than 2, so I'll go that way. Solutions. 15 minus 7p plus 8p, this becomes 15 plus p is greater than 15 minus 2 is 13. I will go ahead and subtract 15 from both sides. I'm just going to verbalize it. I'm not going to write it because to save time. You have to, though. Minus 15 on both sides. So p is greater than negative 2, negative 2, negative 1, 0, negative 3, negative 4, 1. It's going to be an empty circle. Greater than means to the right. If you also think about it, negative 1 is greater than negative 2. 0 is greater than negative 2. 1 is greater than, because all positive numbers are greater than all negative numbers. Oof, okay. So this last question here, or I do believe it's last, might be second to last. No, it's last. You have $15 to spend on groceries. You have $12.25 worth of groceries already in your cart. So how much more money you can spend on groceries? Well, if you only have $15, that's all you can spend, right? So 15 is the cap. So whatever you spend has to be more than 15 or less than 15, right? If 15 is the cap, whatever you have to spend in total has to be less than 15. So I'll say M is what you can still buy. $12.25, you already got $12.25, and the total, you got to add them up to find the total, right? And it could be, if you spend exactly $15, you're still all right, so equal makes sense. And otherwise, you got to spend less than that, right? So to solve, you'll subtract $12.25 on both sides. Subtract, write down $12.25, and then you get 15 minus 12 is 13, or sorry, 15 minus 12 is 3, 3 minus 25 cents is 2.75. All right, and that's the end of this section. Again, like I said, if you get chapter 1, this is just an extension of chapter 1. You replace an equal sign with an inequality sign, but inverse operations work exactly the same way. If you see an addition sign, probably consider subtracting it. And if you do it on one side of the inequality, you got to do it on the other side as well. Good luck.